We'll go with 44. Talk about lines and angles. So this first part is a review. Okay, review meaning that we've already done it, right? So I want you to take a minute, and I want you to fill in these 5 questions, or 5 blanks, not all of them are necessarily questions. Okay, so for the first one it says, what are points that lie in the same plane called, oh, y'all are not second period, hang on. Points that lie in the same plane. Alyssa. Coplanar. Y'all agree with that? Yes. Very good. Because they're in the same plane, they are coplanar. Thank you. Right. 2 angles whose sum is 180. What would that be? Andres. What? Supplementary. Y'all agree with that? Yes. Okay. Supplementary. Abbreviate that. What is the intersection of 2 distinct lines? What would that be? Letty. The intersection of 2 distinct lines. Okay. Almost. Like, so close. What is it? Exactly 1 point. Good. 2 distinct lines. It is exactly 1 point. Exactly. That word exactly is important. All right. Pair of adjacent angles whose non-common sides are opposite rays. What would that be? Molly. Okay. So, do you know what adjacent means? Okay. So I'm gonna have 2 angles, and they're gonna share this side and this vertex. Okay. So that's their common side. Their non-common sides are opposite rays. So it's a linear pair. Good. And so then here are your opposite rays. So you see how you can kind of build that from what it is, even if you're not sure, right? So very good. Thank you. It's a linear pair. So drawing a picture, even if you don't know what the answer is possible and can help you get there if you're stuck on it. Think about what it's trying to say. Okay. Pair of non-adjacent angles formed by 2 intersecting lines. What are those called, Elias? Okay, so here's my intersecting lines, right? So there's intersecting lines, right? Don't be telling them the answer because your name ain't Elias, right? Pair of non-adjacent, so these are adjacent, right? That makes these non-adjacent. So when you see the angles, when you see them, what are these called? They make a V. Okay, look at your notes. Vertical angles. Okay, good. Vertical angles. All right, everybody good with all that? Okay. So, parallel lines. I want to know, what do you know about parallel lines from Noah? Tell me about parallel lines. They never intersect. Okay, y'all agree with that? Yes? Okay. So, parallel lines never intersect. That is a true statement. Is that the definition? Is that what you know the definition as? Yes. But you know the answer is no, or I wouldn't be asking the questions. I always know. So if that's not the definition, anybody know what it is? Okay. Why are they coplanar? No, come on. Okay. Right. Okay, so if I have parallel lines, so you're telling me that parallel lines never intersect. We all agree with that, right? Do we all agree that they would always have to be coplanar? No? What if it's like this? Are they still coplanar? Are they like this? Like this? Right? Even if they're like this, are they still coplanar? Right? Is there a plane that can go through both of these lines? Yes. Okay? So you're right. That's what's missing. And that's important. Okay? It's not just that now we're talking about coplanar, so now we have to talk about that. It's because if I don't have that, then that's not enough for the definition. Because if I have lines that look like this, are they going to intersect? If I've got one on the ceiling going this way and one on the floor going this way, are they going to intersect? No, if the ceiling and the floor never intersect, these two lines are never going to intersect. Are they parallel? No, right? Because parallel lines, they're stay the same distance apart all the way across, right? It's the same distance apart the whole time. Here, they're not, because the distance from here to here is different from the distance from here to here. Does that make sense to you? Okay, so these are not parallel lines, but they are two lines that don't intersect. So just saying that parallel lines are lines that don't intersect is a true statement, but not enough for the definition. Does that make sense to you? We're good? Okay. So parallel lines are coplanar and do not intersect. Okay. All right, so I want to know, what do you know about perpendicular lines from Jenny? Okay. They intersect at one point, because any lines that intersect at one point, so that's true. But what makes them perpendicular and not just plain old intersecting lines? Shouldn't be a new word for you. Somebody want to help her out? Aiden? Yeah. They form a 90-degree angle. Does that sound familiar? Does that sound familiar, Jenny? All right, so Jenny, they intersect to form 90-degree angles. How many 90-degree angles do I get? 4, right? Okay, because if they intersect, let's think about this. They intersect, well, here, let me draw the picture. Let's do this right. Let's write this first. They intersect to form 90-degree angles. Intersect to form 90-degree angles. Oops. My board's being really extra weird today. So I'm actually going to draw them up here. So here are my perpendicular lines, right? When I label that they are right angles, I don't have to label all 4 of them and put a box in there. Because if I do this, that implies that, or that tells you that this is a 90-degree angle, right? So what type of angle pair are these two? Linear pair, right? And so if they're a linear pair, then they have to be supplementary, right? So if this one's 90, what does this one have to be? 90, right? And then what type of angle pair are these? Vertical. And they're congruent, right? So if this is 90, this is 90. And then same thing with these, they're vertical, or you can use a linear pair here. But basically, labeling one of them is enough to say all 4 of them because all those other things apply. Does that make sense to you? You don't have to do it all, and then you just have like way too much on your picture, okay? The symbol for perpendicular, anybody know what that is? It is an upside down T. So the word perpendicular, it is an upside down T, like this. Perpendicular is a long word. I'm not ever going to write it again. I'm going to use that symbol, so make sure you know what it is. Don't be saying, what's that upside down T? It means perpendicular. It's not an upside down T. Okay. All right, so these two, none of this stuff so far should be brand new to you, maybe parts of the definition. But then we have skew lines, okay? And skew lines are new to you, most likely. Anybody heard of those before, or could you tell me what they are? Okay. Do you know what the term askew means? Like, I hung it on the wall, but it was a little askew, or whatever. It's kind of off a little bit, a little crooked, right? Okay. So it's not really, like, doesn't really mean crooked here necessarily, but I think if you kind of tie it to that, it might help you a little bit. So these are your parallel lines, right? These are skew lines, all right? So skew lines are the other lines that don't intersect, okay? Those are the only 2 types of lines that don't. Parallel lines don't intersect, and skew lines don't intersect. So could skew lines ever be in the same plane? No, because the only ones that are in the same plane that don't intersect are going to be parallel. Because if they're like this and they're in the same plane, they're going to intersect at a point. Does that make sense to you? That's why if we think about one in the ceiling and one in the floor, then the ceiling and the floor are never going to intersect, so neither are these lines. So they can't be in the same plane, and they don't intersect. Okay, does that make sense? Parallel lines are in the same plane and don't intersect. These are not in the same plane and don't intersect. Okay, so skew lines are non-coplanar not parallel, and do not intersect. The whole not parallel thing, like one of these two, we could leave off. Because if they're non-coplanar lines and they're not parallel, that's impossible for them to be, actually just non-coplanar is enough. That's the only way to be non-coplanar is to be not parallel and not intersect. Okay, so it's just kind of a list of things. It's a little redundant for a definition, but it kind of gives you all the pieces to make it make sense. So they're not in the same plane. They're not parallel because parallel is always in the same plane, and then they also don't intersect. Okay, we good with all that? And then what I realized I didn't give you was the symbol for parallel. When you see the symbol for parallel printed, like on a worksheet or in a textbook, then it's going to look like two vertical lines, but written, it's usually slanted a little bit so that it doesn't look like an 11, or that it's, so it's not weird and confusing, because otherwise it might look like a random 11 inside of something. But that represents parallel, and then the upside down T is the perpendicular. And so we'll use those for those words when we're writing stuff as well. Okay. All right, so then parallel planes. Do parallel planes intersect? No, because they're parallel, right? And you can't say that they're parallel and coplanar. That doesn't make any sense because they are planes. So really enough for parallel planes are just planes that do not intersect. I'm sorry, what? Mm-hmm. All right. So using the figure to the right, we're going to identify the following. Okay, it doesn't matter. Be quiet. All right, so a pair of parallel segments. Now, we have definition of parallel lines. There is no definition of parallel segments, but a segment's part of a line, so a parallel segment's part of a parallel line. Make sense? All right, so a pair of parallel segments. So I want you to look at that. I want you to think about it. I'll give you a minute to go ahead and kind of fill these out. All right, see if you can come up with a pairs of each one of these and write them down. Okay, give you a second to think about those. All right, so parallel segments. Marco, can you name me a pair of parallel segments? B and F. Okay, B and F are points. Okay, except I want a pair of parallel segments. Thank you. So line segment BE. And so I want to make a statement that they are parallel. So that's how. Now, if you have different ones, it's fine. You don't have to erase them because you may not have chosen those. It's all good. That's why I gave you some time to do your own. We'll talk about that in a second. But I want to say that they're parallel. So the statement I can make, and you can add these if these weren't yours, and then we can talk about what other options are. Line segment BE is parallel to line segment FJ. Okay, so line segment BE is parallel to line segment FJ. These little arrows on here do not mean congruent. They mean parallel. You've seen that on parallelograms before. You may not have been told what it means, but you have seen it, because I know it's been labeled that way, but it may have you may have just thought it was decoration. I don't know. But these only have one little arrow on them because it means all four of those are parallel to each other, and then these have two because all four of these are parallel to each other. It has nothing to do with congruence. It's about being parallel. Okay, so these are the segments that he named. Are there other options? Absolutely. The important thing here is that you're naming them as line segments, that you make the statement that they're parallel, and that you don't assume anything that isn't happening. So if you picked any two that had the same amount of little arrows on them, you're good. Okay? Okay with all that? All right, so a pair of skew segments. Let me think about that. Mariah. So she's saying line segment CD and line segment, what was the other one? FG. Okay, do y'all agree with that? Those ever going to intersect? Nope, they're sure not, so that works. And so there's not a symbol for skew, so I would write CD. Basically, I could just list them, CD and FG. If I had to write out a statement, then I could say CD and FG are skew, but I don't need to do all that. Tell me about line segments BF and line segment BF and line segment DH. BF and DH. Are those parallel or skew or intersecting, or what are they? Parallel. Okay? So we know that because they have the little arrows on them, right? That means they have to be coplanar. Are they coplanar? Yeah, because first of all, they have to be, right? Because they're parallel. But remember, you can have this plane that goes through diagonally through there, and so that's how they're coplanar. All right, so a pair of perpendicular segments. Aiden, what would be a pair of perpendicular segments? Okay, line segment BF and line segment BE. Okay, what do y'all think about that? Yes, okay, so how do you know they're perpendicular? Is that what perpendicular means? What does perpendicular mean? How do you know that? Okay, so we don't know, right? Do you know that for sure? So what could you tell me, Aiden? Which ones do you know for sure? Y'all agree with that one? Yes. So BF and FJ are actually your only options for answers for this one, because that is the only one that's labeled. Anything else is an assumption. Assume nothing. All right? So to make this statement, it's line segment BF is perpendicular to line segment FJ. And actually, the segments he gave me are perpendicular, but you don't have enough knowledge of parallelograms and quadrilaterals yet to be able to explain to me why. So it is an assumption, because most likely you weren't thinking through that anyway. Yes, sir. Go ahead. That's how we know for these two. But he was trying to tell me these two, and we don't know that for sure. Then which one? BEJ? Well, because I could have this, right? That's why we don't know. Just these two. These two are the only ones that are labeled. That's it. That's all you know right now. It's the best you can do. You do not have the tools in the toolbox to give me any other answer, I promise you. All right, so a pair of parallel planes. Do we have a bunch of options here? Yes. Okay, and when you name a plane, you have to use the word plane, right? These are represented by quadrilaterals. Do I use all 4 points? No. Okay, so let's see. Which ones do we want to use? Let's just use the top and the bottom. Okay, so if I'm going to use the top and the bottom, I'm going to use this one. I could use any of these 3 letters, but I don't use all 4 of them. So I could just call it plane BCD. Right? And then that's parallel to, I left off the blank here, plane F what? FGJ, that totally works, FGJ. Okay. Everybody okay with that? And the other ones would be fine. You could either way. All right, next page. So we have 2 lines cut by a transversal, right? And that's what's going on here. There's a total of 3 lines. The angle pairs that we're going to be looking at the next couple of days, you look at 3 lines at a time. If you have more than 3, you've got to cover up and ignore anything else that you have, or you're going to get yourself confused on some of these, okay? So this is 2 lines. A third one intersects it, right? Are these 2 lines R and S, are they parallel? No. Okay, maybe, we don't know. They don't look like it, but they're not labeled that way. So chances are pretty good that R and S are going to intersect as well, right? And that's fine, because we're not talking about them necessarily being parallel right now. But the third line, right, a blank is a line that intersects 2 coplanar lines, okay, so we're only in 3 dimensions when we're doing this, at 2 different points. That's important because here's what's happening. If I have these two lines, all right, so that's two lines. Then I'm going to draw in this third one. Does my pink line intersect my two purple lines? Yes. Does it intersect it at two different points? No, it does not. So this is a big no. This is not the situation we're looking at. They all intersect in the same point. But if I have this, okay, so here are my two lines. And then if my pink line goes through like this, my pink line intersects the two purple lines, but does that intersect at two different points? Yes. Okay. So this works. It is possible for those two purple lines, or what represents the purple lines, to be parallel. In that case, they're not. In this case, they're not. But we're just looking at that third line intersecting the other two, and it has to be at 2 points. Okay? So that line is called a transversal. Okay, so a transversal is a line that intersects two coplanar lines at two different points. So the example for that here would be line T. And then I'm going to have to scroll, so you're going to have to look at your own picture. You're not going to be able to see mine. We're going to skip number 2. We're going to come back to that one and actually do it last. So skip to number 3. Okay? So 3 are angles that are non-adjacent. They're non-adjacent angles that lie on opposite sides of the transversal T between lines R and S. Okay, so the two lines that we have, here are my two lines. You see how this is orange in here because this is the interior, this is the exterior. It's not necessarily a closed figure where you're used to thinking of inside and outside. If I give you a circle, interior and exterior is totally clear, right? When I give you this and it's not a closed figure, and maybe if they're parallel, it never is going to be, the interior is just between those two lines. That's all it means, okay? So we've got interior and exterior angles that are going to be talked about with those words. So it's important to understand what's what. So these are non-adjacent that lie on opposite sides of the transversal T between. So they're on the interior. They're non-adjacent, which means it can't be 5 and 6. Are 5 and 6 on opposite sides of T? Yes, but they're adjacent, so those don't count. So they have to be non-adjacent and on opposite sides, so it would be like 4 and 5 or 3 and 6. You see that? Okay, so these are called, instead of the word opposite, we use the word alternate. So these are alternate. Make sure you're on number 3. Interior angles. So that would be like angle 3 and angle 6, angle 4, and angle 5. All right, so then the next thing we have are non-adjacent angles that lie on opposite sides of the transversal outside the lines R and S. So if we look at our picture, they have to be exterior angles on opposite sides. 7 and 8 are on opposite sides, but they have to be non-adjacent. So that would be like 2 and 7, 1 and 8. And anytime they're on opposite sides, that's we use the word alternate instead. So these are alternates, but they're on the outside, so they're alternate exterior angles. So it'd be like angle 1 and angle 8, angle 2 and angle 7. Then we have these angles that are also called consecutive interior angles. That's actually what your textbook uses, but it's not the best term to use. They lie on the same side of the transversal between lines R and S. So between lines R and S means it's on the interior, and they are on the same side of the transversal. So on the interior, my transversal is T, so these two right here are on the same side of that, both on the inside. Are 4 and 6 a linear pair? No. Are they connected by a line? Yes, that's not what linear pair means, okay? These are not adjacent angles, so they can't be a linear pair. But they are both on the inside, both on the same side of the transversal, so these are called same side interior. Makes sense, right? Oops. Same side interior angles. So it's like angle 3 and angle 5, angle 4, and angle 6. Then we have angles that lie on the same side of the transversal outside lines R and S. What do you think those are called? There you go. Same side exterior. So those four names have interior and exterior in them. They're either alternate or they're same side. But then we have number 2 that we skipped. We go back up to number 2. Blank angles are, so they're non-adjacent angles that lie on the same side of the transversal on the same side of lines R and S. Even though everything's happening on the same side, these are not same side angles. We don't use those words in this. It's because it's a different thing. Because actually one of them's on the inside, one of them's on the outside. So if they lie on the same side of the transversal on the same sides of lines R and S, okay, so like 1, 3, 5, and 7 are all on the same side of the transversal, right? But they also have to be on the same side of R and S. It is not 1 and 7. 1 and 7 are same side exterior. But if 3 is underneath R, 7 is underneath S. So 3 and 7, they're on the same side of the transversal, the same side of that. They're in the same position. If you look at these as you have this set of 4 and this set of 4. 3 and 7 are in the same position. 1 and 5 are in the same position. Does that make sense to you? Think about how you're sitting at your tables, right? Elias and Kevin and Sebastian are all in the same position at their tables, right, as your little set of 4. Okay, so they're all sitting in corresponding seats. His seat corresponds to his, which corresponds to his. Does that make sense to you? So these are called corresponding angles. So don't see that things are on the same side and then automatically think they're called same side angles. It depends, because if one's inside, one's outside, then that makes them corresponding. Okay? Everybody okay with that? Any questions so far? These words not brand new to you, right? You've seen this before? Okay. Did you use consecutive or same side? Do you remember? You don't remember? Okay. Same side is, yeah, I tried when we got the new textbook to switch over and I was trying to be consistent with the textbook if you actually went back and used it, but nobody actually goes back and uses it. But it's, same side makes so much more sense for a lot of reasons that we'll get into tomorrow as well. Now I remember what I wanted to say at the beginning of the class. I had a conversation with a parent last night about textbooks, and you have a digital textbook. It's in your syllabus how to get to it. It's on the portal. You have to click on the little thing and you can get there. But the top of your notes, if you look back on the front of them where it says notes, lines, and angles, and then it says section 3.1, that should always correspond to the actual section in the textbook. So if you do need extra help, you can go to 3.1 in the textbook, and there you go. There's little tutorial videos and little practice quizzes, whatever, but that's how you would find it. You could also always look it up in the index, but that actually does mean something up there. Okay. All right, so let's look at here. It says, give an example of each angle pair. Use the figure to the right. All right, so we're going to go through these together so that we can save some time here. Corresponding angles. Remember, they are in the same position. So I've got this set of 4 and this set of 4, right? So if I start with angle 2, angle 2 is a corresponding angle with which one? 6, because 2 is in the top right, 6 is in the top right. Does that make sense to you? Okay. All right, so alternate interior. Now, this right here is my interior. This is the exterior, because these are my 2 angles. This is my transversal, right? So alternate interior angles, if I start with 3, what's the alternate interior angle with angle 3? 5, because they're both on the inside on opposite sides of the transversal, so it would be 3 and 5. And there's more than one answer for all of these, but we're just not going to write them all. Alternate exterior angles, so they're both on the outside, opposite sides of the transversal. So if I start with angle 1 and angle 7. Everybody okay with that? All right, same side interior. So they're both on the inside, on the same side of the transversal. So if I start with angle 6, which one is same side interior? 3. Okay, stop me if you have a question. All right, vertical angles. If I start with angle 3, which one is vertical with that? Angle 1. And then a linear pair, if I start with angle 7, what's a linear pair with 7? Angle 6 or 8. So I can do angle 7 and angle 6, or angle 7 and angle 8. Everybody understand why there's 2 options there for that one angle that we start with? Are there more linear pairs there? Yes, there's more of all these, but we're all good? All right, next page. So this is kind of a review of what we'd already looked at. So we've got parallel, right? This is your symbol. They're in the same plane. These are actually not written out very well. This right here, this should say line L is parallel to line M. The word line should be there. Perpendicular, here's your symbol. And again, this should say line K is perpendicular to line L. Then skew, they do not lie in the same plane and do not intersect. This should be line K and line M. We good? All right, so let's look at number 1. This says a pair of parallel lines. All right, so here's what I know before I ever even start. When I look at these lines that are over here, am I going to name them by their little lowercase letter, or am I going to name them by 2 points? Little lowercase letter, right? And so when I name lines, I have to have the word line. So it's going to be line something is parallel to line something, right? So you want to make sure that you're actually naming them the right way. And then the ones that are parallel are which ones? Okay, G and what? H. Okay. A pair of skew lines, so it's going to be line something and line something. So are J and G skew? No. Is this a 3-dimensional picture? Yes, it is. That's why there's that dotted line there. You got to be able to look at them. Okay. So J and H. J and H. Because J pokes down through that plane. And then name a pair of perpendicular lines. So line J is perpendicular to line G. Those should be super easy questions based on this very simple picture, but I just wanted some writing practice of how to name these things. Okay. Everybody good with all those? Okay. So now we're going to look at a segment that is parallel to line segment DG. So here is DG. Which one's parallel to it? FJ or JF. And could HE be parallel to it? Yes, but do we know that for sure? No, so FJ is really our only answer. A segment that is skewed to JF. Could I use HE? No. Could I use DF? No, because they intersect, right? Could I use DE? Here's JF. Here's DE, right? So this would be good. Yep, because they're going to look like this. That's what we need. All right, one pair of perpendicular segments not including GH. So I can't use GH and HJ, but the only other ones I have are DE. I could say DE is perpendicular to what? FE, and you've got to make sure that you're naming the segments like you're supposed to. A segment that is perpendicular to GH. What's perpendicular to GH? HJ. one pair of parallel planes. Is there even more than one pair that exists on here? No. Okay, so I know I have to say plane something is parallel to plane something, right? And so those will be the two triangles. I only have 3 letters anyway, so DEF and GHJ. Then a pair of skew segments not including JF. So let me start with DF. DF and what could I use? GH. Do you agree with that? Here's DF and here's GH behind it. That works. Okay. Any questions about any of those? Nope.